Yeah, I'm Mike Carlson, if you haven't met me, and I work for the Houston Bridge section, and like she said, been there about 5 years. And when I got there, I noticed a few things, and with help with the management, we've kind of had to do some changes in order to get some of these really, really fast projects, which I'm sure you all are getting as well. If they need it done in last year, if it needs to be done in 2 months, next year it's going to need to be done in a month. So it's just, you give a mouse a cookie, he wants a glass of milk. So anyway, hopefully you take away something from this presentation that can make you help speed up your design. Anyway, if you aren't familiar with the Houston area, 290 is our northwest corridor, and it was on the top, whatever, the 100 most congested highways at one point, and it probably still is. And we're trying to remediate that. It's divided into 13 segments, starting all the way down at the inside loop of Houston at 610 and going out towards a long way out. As you can see, there's a little bit more detail here. If you want to see this, I'm sure the presentations will be posted somewhere someday. But you can also go to myus290.com or something like that you can find all these this graphic as well. Most of the segments have let by now, about 80% of it. You can see any of the lower columns that are filled out have let with a variety of different contractors out there. Anyway, like I was saying, it's 13 total segments. Our design started in about 2009. And we definitely foresaw a compressed letting schedule coming up. HNTB was the project manager, management coordinator for the project. And we were provided initially with bridge layouts from a variety of consultants. Later on, we had a few in-house TxDOT roadway design groups develop them. Currently, we're at about 23 total employees in our section, so it's a pretty big section for bridge design in Texas. We have 14 PEs, 10 of which are actually designing, 4 CAD operators, and some BRINSAP personnel and administrative. And if any of you are old-timers, you remember J.C. Liu when he was in charge of our section, we had about 33 people back then. So we're running at about 2/3 capacity in terms of our staff, but on top of that, we've lost a lot of experienced people. John Holt of Houston, Kenny Ozuna, John Vogel. I know many of you know John Vogel. Anyway, so we're not only dealing with 2/3 the people, but a lot less experience. Initially, when we started the design, we had about 14 people doing the actual 290 design. And here's kind of a breakdown of the winning bid and when they were, how many bridge sheets. We actually have submitted over 5,000 bridge sheets to this date, and about $1.1 billion is let. I put this graphic in here. I wish I had a little bit better data to produce y'all a Gantt chart, but P6 was kind of starting at the same time we started all this. But what I did was I took the timesheet data that we've submitted for the Function 170 design, and the top is 100% of that whole project, the amount of time we took to design the project. And as you can see, all these bars are cramming up. We had multiple segments running at the same time. Starting at the beginning, we had the one segment. We had to get our act together because the next, in 2011, 12, and really 13, it all was going to compact on each other. And we didn't have enough time to go back and change something or dilly-dally and yet stay on track for the next segment and the next segment. So how did we do it? Well, first we decided we're going to have to change the responsibility and how our teams work together in our section. So this is the traditional way that we normally design bridges in our section. We have our division, or our director is Ken Lin now, and we have a few project managers, I'm being one of them, and now we have a few design engineers and some EITs and a CAD operator. So the project manager gets a bridge, and you complete a bridge, and another project manager gets another bridge. So when you're doing with a lot of bridges along a corridor, you're going to end up with different results because you have different people working on the different bridges. So here's what we decided to do. John Holt of Houston came up with the idea of we got to take all these little components of structural design and spread them out. So We're going to find one engineer, he's going to do all of the bent caps. We're going to find another engineer who's going to do all the BGSs. We're going to have another engineer doing all the pre-stress 14. At the time, there was no PG Super yet. And the U-beam design, and et cetera, and foundation. And as you can see, and then we even had CAD operators that would specifically focus on one thing. So we'd have a substructure CAD operator and a superstructure CAD operator. So this mass production way that we're doing this kind of has definitely some pros. First of all, if you're the guy who does all the bent caps on the job, you're going to figure out a way of standardizing as much as possible. You're going to try and say, I'm going to make one cap that's going to work for a big variety of different cases, and then I'm going to make a dividing line and say, okay, I'll use this other cap for the next group of cases. So in essence, it forces the engineer to standardize because the engineer doesn't have time to just start from scratch on every single different bridge. And it also then creates more of a consistency. So we've all had cases where we have one engineer that designs a 3-span overpass on one overpass, and right down the road there's another overpass that has completely different details, but it's very similar. And I'm sure the contractor's going, well, why? Well, it's just because the two engineers didn't talk to each other and standardize the procedure. Well, with focusing on one engineer doing all the bent caps, we eliminate that problem. And it also provides consistency of architecture elements. And we have other ways, and I'll get into those, and how we want to consistently make our architectural scheme consistent. But certain things like the inverted T-cap depth, that may, we say, okay, we're going to use inverted T-caps, but one engineer may decide he wants the ledges a little deeper or the stem a little shorter, or et cetera, et cetera. So by doing this, we ended up saying, hey, let's keep it all consistent looking. Maybe the public won't notice this, but I know we go out there and we can scrutinize it a little bit more. And then on top of that, we reduced the redesign of similar elements. I already got into that. But create a library. Say, okay, if I have spans of 100 and 110, well, 100 and 105 feet is about the same as 100 and 110. Let's just use the 100 and 110 foot span design for the 100 and 105 feet. So that encourages the designer to make a library, and then even they can go to another bridge and say, hey, this is exactly the same as this other one. I can re-pull the design up. I don't have to do it all from scratch again. But it had some challenges too. First, we needed our layouts to be really good, 100% complete, because we didn't have time to go back and say, oh, we changed our alignment or our profile, et cetera, et cetera. And thankfully, this job, we were pretty good at the start with that. And we have to make sure we're talking with other engineers, or collaborating with our engineers together. The guy who's designing the superstructure, he needs to make sure he's telling the guy who does the substructure, hey, I got 4 beams here, 5 beams here. Otherwise, you're gonna end up with an inconsistent product. And then our CAD operators had some concerns too, because we had multiple people going in and out of files, and they were kind of the old school technique of saying, hey, this is my drawing, nobody touch it, I take responsibility for it. So that was some of the challenges we also had to overcome. And then on top of that, we had some increased burnout. Just if everything's never slows down, you're going to burn out your personnel. And at the same time, if you're the guy who does all the bents all the time, you get a little rusty with your BGS and your pre-stress 14. So if you're doing that for a year. Like I said, we standardized a lot of our architecture, design, and detailing. If you're not familiar with the Houston area, Kenny Ozuna worked really hard with an architectural committee several years ago with the Katy Freeway project, and they developed the green ribbon scheme. If you go to Houston, there's 3 schemes. There's vertical scheme, horizontal scheme, and wave scheme. The vertical scheme is up north, and it looks like the pine trees for the Piney Woods area of Texas. Horizontal scheme is out west more, and then the wave scheme matches the coastline. The interchange scheme is a little bit beefier columns for the big interchanges, and it kind of mimics the horizontal scheme. So we had this to start off with, which really helped. It's part of our standardization. Hey, we're going to make all of our overpass flared columns look the same. So, et cetera, et cetera. But we took it a little bit further. We said, well, if we're inside the loop, if we're closer inside, we're going to use all U-beams. And you know what? Why don't we just use all U54 beams? There's no reason to have U40 beams unless we got a clearance issue or something like that. So just use straight U54s to keep everything looking the same. And we developed standard inverted T-caps so that everything matched for along the whole corridor. And then the column details, which were already set up for the green ribbon, those were all standardized. So you just pluck a column and fill out your table. And then on top of that, we even developed a whole footing details library. So every single footing along the whole 290 corridor has actually got its own name. If you're from segment 2 or segment 9, and you need that footing, you just pull it from that file, you stick it in with the same name. If it's DSF 22, and that's the only footing, you put in DSF 22. That way, we can keep everything organized. Again, like I said, with the standardizing, design engineer pros, you don't have to, when you're faced with hundreds of elements to design, you're going to be forced to do it anyway. And you're encouraged to create a library of that so you can go and reference back and say, well, I have this bridge over here, it's exactly the same or very close to this one over here. The CAD operator pros, drafting takes a long time, so we actually we encourage the reuse of, by standardizing, we encourage the reuse of as many drawings as possible. And that way you could get a go-by and just mark up a few little things, give it to them, and they could go with it. And they also become a little bit more familiar of the drawing. They may be able to point out something, hey, you took this note away, did you mean to do that? Oh, okay, I didn't mean to do that. So they get a little bit more familiar too and kind of offer a secondary check. We changed the priorities. We started drawing sheets before they were even designed. If you got a roadway and it's this width and you know your bents are 90 degrees, you go pull a sheet that's close to 90 degrees, you start dimensioning it up, give it to the CAD operator so they can start drawing it while you finalize a few other things. That way they're not twiddling their thumbs while you're doing the designing and vice versa. Some sheets, they didn't need to be drawn to perfect scale. Some things we already had and they were 62 feet and we needed 62.2 feet. Whoop-de-doo, just change the dimension and run with it. And then another thing that I've been trying to get on a lot of our people is to make sure that you get one element done perfect before you make copy. We have lots of bridges out there, 10 bents. They're all the same bents. And we repeat the sheet, and I know in our district we like to make bent 2, bent 3, bent 4. We don't want to do bent 2 through 10 because then something will change and then we have to go and figure out how we're going to slip that in there. But I have so many people still, even to this day, they'll give the CAD operator bent 2, bent 3, bent 4, bent 5, bent 6, all redlined. Why don't we just get bent 2 done first, make sure you're happy with it. Then when you're happy with it, let's make copies and then make many minor adjustments that we need to. Again, break down this, simplify the red lines between the CAD operator and the engineer. You don't have to make the whole sheet in red first. You can go and get the base drawing fixed first, so you can redline that, get that finalized, then come back and put in elevations or quantities or something like that. It gets really confusing to a drafter when the whole thing's red. What's the priorities? And they're bound to miss something. And then we also sat down and scrutinized, make sure, really, do we need this extra information on the plans? Are we repeating information? Because, I mean, that can get us into trouble, too. If something changes or we mismark it and now we got conflicting information. Or something changes, and then you got to remember to go back and change them on all these sheets. So if the information's repeated, that's not a good thing. We work smarter. Well, we live in the 21st century now. We need to let the computer do the heavy lifting. When I got here at TxDOT, I realized the biggest waste of time for us engineers and CAD operators is data management. We are constantly taking information from this program, putting it into this program, typing in this information, writing down this information for them. They're retyping it in, we're rechecking it. And there's no real reason that we have to do that. It takes up a tremendous amount of our time. And we would much rather spend our time doing good design and checking the design than to just type numbers. So, work on designing your spreadsheets so that they can be easily adaptable. Let the standardization work for you. So if you standardize your bent caps, then guess what? You can make your one spreadsheet that works for those type of details. You don't have to go and make a whole new one for a whole other type of details. And by our new work group, the way their teams were organized, this was encouraged automatically again for the engineer to do this. Design them so they require as little tampering as possible, but they can also be easily modified for different situations. Sometimes that requires a little bit of extra ingenuity. We like to just throw together something real quick, and then we realize, hey, we go to another piece of the design, and I did that before, but it takes so much time to modify this, I basically might just throw it out and start over again. Well, if you put a little bit more upfront time, thought into it, you may be able to make it so it's easily adaptable. And then, when you do get some downtime, like we did back in that 2009, right after our first segment, figure out what worked good and what worked, which could need a little bit of polishing, and improve your tools so that when we got to 2013, we were running even faster. And when possible, get your tools to work together. If you had, and I'll show you an example later, where we have column elevations, and they work well with our foundation tables. So you just take and copy, and it's all formatted the same way, and you don't have to go and adjust and finagle with it. And then one thing that I added here that I'd kind of like to push for anybody, including division, keep your ears open. Let's work at finding tools and developing tools that require the input only one time. Why do I need to go to the foundation design tool and re-enter all my information for my superstructure? Why can't I take my superstructure stuff? It should all be filtering down to the foundation. I don't know if you've seen that before, but that's actually from one of our engineers in our section, and this is kind of how it was done before I got here. They would just calculate everything and write it in our bar table. Well, this is a tremendous waste of time, because now it took the engineer so much time to write this. The drafter has to find it and 10 key it all in, and then the engineer has to go back in and verify that because you're bound to have one or two numbers that's not going to be right. So we definitely, I pushed for using Axiom, and I know a lot of people probably know about Axiom already, but some of you may not. Use Axiom whenever you can to take and develop as much in your spreadsheets to the same format that you'd want on a sheet, and then you can just paste it in and you don't have to worry about it. This did have a little challenges because, again, like I said, we had our CAD operators. They liked the ownership of their files. They didn't want an engineer in there, and we had to work kind of with them to say, hey, look, you get this all done. I'll go back in and I'll put the table in later. So this will be my little area of the file. And they were a little skeptical at first, but they're much happier now. They really don't like doing this anymore. We also developed a few more advanced tools using macros and spreadsheets. One thing that's about these old Fortran programs is they're nice and predictable and where their outputs are. So we developed spreadsheet tools that could extract the pertinent information from BGS. BGS, we know where everything is in BGS, but sometimes you got to go through it and find all those the little pieces. For instance, your slab areas for your quantities. Well, that seems easy enough for a simple 3-span overpass where you're going to do how much is my slab area. I can find that in the slab report. But in connector C, which is actually going to connect I-10 to 290 without getting onto 610, it's 95 spans long. It was over 11,000 linear feet. Do you want to go down each BGS and copy that information out? So we developed the extractors here to you click the button, you just load the file, you click the button, and it loads all the information from each slab report. Tremendous time saver. Rebar quantity tables. Again, we were standardized, so that way I knew the same details were going to apply for all these bends. We only had a few separate detail cases, so develop the tool to calculate the rebar quantities and to axiom it into the CAD file, And I got it down to a point where all you got to do is put the length of the cap in, the skew, and where your S-bars are, and everything else populated itself. And this really, really substantially did away with a lot of our quantity errors. We have not had any major quantity busts in any of these projects with these tools. And I know we're moving forward now because a lot of this is kind of, we were doing back in 2009. I know Division's been talking a lot of things about like rebar, Bentley rebar, and that's great. That's moving ahead, but it also has some disadvantages as well. Like I said earlier, we would just change our dimensions on our cap just slightly. Well, rebar, you have to draw everything 1-to-1 scale, so you'd have to readjust and redraw each bent cap for it to calculate. So for now, I think I'm going to stick with this. Here's an example here. Left table was all automatically generated and just paste right in. Very minimal need to mess with it after it was in MicroStation. Column and foundation tables, like I said before, we developed a whole library full of footings and columns, and every column was unique. You could pull it for any job, any segment, and say, I want column A and footing DSF2, and they would work together, and the tools, you just enter it in, and the library would look it up, and your number of drill shafts, the size of drill shafts, the footing height, all the elevations would adjust, the shoring quantities, if it's mass placement or not mass placement, it would all figure it out automatically, so you wouldn't have to, really mess with it. There's some examples of the column tables in our green ribbon column. And again, the column and the foundation spreadsheets work together. So that was something that you should think about. Is like, oh, I have this information that needs to come out of this one and go to this one. Well, let's make the fields so that you can just copy and paste it and you don't have to finagle with it. And there's foundation tables, examples. And then we went into U-beam design. Now, I don't know how many of y'all have designed U-beams, but they're very tedious. You basically, before PG Super, which PG Super is still part of this inserted set here, but you got to run BGS 2 times. You got to compute all your live load distribution factors using the spreadsheets, or if you're using PG Super. You compute all your loadings and your dead loads and distribute them to your beams automatically, or PG Super does so. You've got to create your input files for Prestress 14, run them, and then use a spreadsheet to compute the drops, which you still have to do. Unless PG Super can do that yet, Amy. And then run BGS one last time. So we said, well, this is taken about 3 days of 1 or 2 engineers' work for each bridge. So how long should it take for a 20-span, 28-foot wide connector, approximately? And it was taken about 3 days. And so there was a guy in 2001 that envisioned a little program, and basically I took it over. It was broken in 2009 and 2014 and redeveloped it, and it automatically will do that in about 3 minutes. So it automatically imports the BGS data, it automatically makes the pre-stress 14s, it automatically computes the live load distribution factors. You just have to do a few little user inputs, and it runs it gives you a summary at the end. And here's an example with the summary of the, I don't know if I get the laser, there's the bearing deducts that we were to use for our final BGS. And then there was only a few little inputs we needed to put up here, and all this would pull in from BGS. This would pull in from pre-stress 14. There's our information from our live load distribution factors, and then it would tally it up to our total bearing deduct. And on the next page, this is an actual example of the automated pre-stress 14 output, which is actually a lot cleaner than even some of our engineers. And then this is our slab sections and deflections that we put on our sheet. So a lot of it just placed nice and neat for you. And then another thing, when you go back and you check, when you have somebody check this, all of the data, if the beam is 118.32 feet long, it's 118.32 feet long right there. It's not 119 because some engineers said, oh, that's close enough. So when you're another checker, it's a lot easier for you to check number equals number than number equals, well, that's close enough. That requires a lot more of your brain's power, and it's much more draining to say, hey, is this close enough versus match, match, match. And then we brought in a little bit of new software. I know I know Division's working with Leap and RM Bridge and a lot of these new software, which is great. And we're doing so in Houston as well. In Houston, we've been using ViArthur VBent for specific cases for a lot of our single column bent caps and footing design. There are some quirks to the program, but we've kind of figured out some of them to get them to match other designs for the other programs. But beforehand, we just had STAD, and that'd take days to develop a STAD model. And this program, we could do some quick, easy calculations, check for our foundation loads, et cetera, in 15, 30 minutes. And here's some screenshots of it. Very simple. You can't do a heck of a lot with it, but it did enough for what we needed. There's footings and rebar, and it would do our spec checks and give us our pile forces. It even did some basic post-tensioning. And straddle caps was another good one that we would use it for. And so how did this all result? Well, we've been averaging about 21 hours per sheet. So depending on the segment, this one right here, segment 6, we had some time, we went back to the old methodology of doing things to get some more engineers kind of up on board of how we do things in 290, so that's why it's a little high. But the rest of them have been running pretty fast because of what we basically started here and then improved as we went along. That's just a different tabular result of that. Anyway, any questions? There's somebody over there, I think. Unless you.
You made mention of standardizing your design for events. And I know Chris had just talked about precast. Was that a consideration when you guys were going into 290?
Well, that's kind of a little bit newer stuff that they're dealing with right now. A lot of this was new construction off to the side, so we kind of just ran with what we felt comfortable with at the time. But that would have been a good thing to look at. But no, we didn't really look into doing precast.
And also, I like the way you're talking about speeding up the process, or not using one program and then putting it into another program, that's just old. If someone wanted to use the programs you have in Vision,
Hey, can you repeat the question?
I didn't get the last. You said you were.
if I wanted to use your spreadsheets,
Correct.
programs or your macros, how can I in Vision get a hold of them?
They are not published right now. We leave them in beta stage. Then this is kind of Houston's own thing, but it does give you an idea that they can be created, and they do have some quirks to them. So it's something that we're not really excited to just release to the mass public yet, because then we could run into issues. But I can work with Division with that if we want to release some of that someday. But right now they're not available. But I did want to just point out to you guys that, hey, you can make stuff like this even in your own office, and some of it didn't take long. That can really, really speed up your time.
Thank you. I think we got a few minutes for a few more questions if anybody's got any. Hold on just a minute.
When you standardized the bents and the caps and everything, did y'all notice a reduction did y'all look at the construction costs with that? Did that reduce the construction costs at all?
We didn't. The question, well, you heard it, but the question, we didn't really look at it and calculate it out per se, but we knew that by doing the standard, we weren't really going to be saving that much in materials if you shrink up a cap by 3 inches here, or you take a few bars out here. We knew that it would have to make a reduction in the construction cost. But also, it gave us a peace of mind, too, because sometimes you go out there and say, I want this cap to have 12 bars here, and that cap to have 10 bars, and that one to have 14 bars. Well, you never go out there and look, and you hope that the contractor put it in that way. So that's also another nice thing of saying, let's just group, and the contractor is happier with it because then they can crank out production faster, but you feel a little bit more comfortable that you didn't kind of complicate it a little more than it needed to be. Because we all know that in today's world, labor is the driving cost, not the materials.